Assalamu alaikum everyone. I am Faiza Fatima from Group 4A1 and my ID is 2100211101. I am presenting our complex engineering project for EEE-4705, a fully functional, standalone, tic-tac-toe handheld gaming device. Today I'll walk you through our project, why we built it, what makes it special, key features, the components we selected, how they work together, and finally, how we organized our software memory map. So first, let's talk about why we made this. We were tasked by a fictional startup called Retrologic to design a low-cost, retro-style handheld gaming device for mass market consumers. The challenge was not just to make a game, but to do it under real-world engineering constraints. That includes low production cost, low power consumption, minimal memory, and input-output resources. Now let's talk about the key features of our devices. The key features are Feature 1, dual game modes. Feature 2, two complementary output devices. Feature 3, intuitive input. Feature 4, full game logic. And Feature 5, smart AI. Now let's talk about the main components we used and how they work. At first comes the microcontroller. This is the brain. It runs at 12 MHz, has 32 input-output pins, 256 bytes of internal RAM, and 8 KB of on-chip flash for our assembly code. We used a crystal oscillator to generate the clock and an RC reset circuit for power on reset. For input unit, a 3x3 push button keypad is used. We chose individual push buttons over a matrix keypad or joystick because direct mapping gives the best user experience. A child or adult can press exactly the cell they want without confusion. For output unit, we use two devices together. First, the 16 by 2 character LCD. This is our primary status display. It shows title screen, current mode, player versus player or player versus AI, then the turn, cross or zero, a compact text board, and win or draw message. Then 8 by 8 LED matrix and max 7219 driver. This is our visual board. We could have driven the matrix directly from the microcontroller, but that would use 16 input-output pins and require complex multiplexing code. So instead we use this one, a dedicated LED driver that communicates over SPI using just 3 pins, DIN, clock, and load, connected to port 0. Then for mode selection, we use SPDT slide switch. A simple single pole double throw slide switch connected to port 0.3 with a pull-up register. For high, we get player versus player mode, and for low, we get player versus AI mode. Then we used power supply. Now let's talk about how the system flows or how everything works together. Step 1. The microcontroller resets that initializes the LCD and max 7219, displays a title screen, and then reads the mode switch and clears the broad array. Then step 2, the program continuously checks for a win or draw. If the game is still active, it waits for a valid button pressed from the current player. Then step 3, the keypad scanning routine identifies which of the 9 cells was selected. If that cell is empty, it updates the board array in RAM. If the cell is already occupied, the move is rejected and the game waits again. Then step 4. The LCD is refreshed with the new board state and whose turn it is. And then the LED matrix is updated. Then step 5. If the game is in player versus AI mode and it is Zero's turn, the minimax algorithm runs, finds the best move and places it automatically without any human input. Step 6. When a player wins or the board is full means draw, the result is shown on both displays. Pressing any key resets the game for another round. All of this runs in a continuous loop, without careful register management and no wasted cycles.
Assalamu alaikum. So as of now, we are already known about the components used here and how these components are working. I'm going to demonstrate this tic-tac-toe game on this Proteus simulation. But before that, let's have a short walk through exactly what's happening on the screen. I mean the hardware and the implementations and the algorithm. On the left side we see there is a LCD. We used LM016L LCD. This is where all the game status will appear, status text will appear, and on the top right corner we have the 8 by 8 LED matrix. We used Max 7219 IC. This is our visual game board. In the bottom center we have our 3 by 3 push button keypad. Whenever I press this key, these indications will be seen on the LED as well as the mm, LCD. uh, then here we can see this is our code. We have developed this code according to our design, and and then we save the .hex file, and then we uploaded in on our microcontroller. Then now we can simulate our program. Just let's run the program. So as soon as the power is applied, the microcontroller executes a 20 millisecond startup delay. Um, but this delay initializes the LCD and LED driver, and at that moment the program is reading the slide switch on pin 0.3 to decide the game mode. Here we can see this pin zero point 0.3 indicates that our game mode is seen P versus P. That means our game mode is player versus player. Two players can play this game. uh, Now let's proceed how this works. Let's there are two players. Let's say one player is player X and the another is player 0. Now let's say I'm pressing the center button, this one, and the X symbol lights up in the center of the grid. We can see that here, and the and then the LCD displays here. We can see the X symbol is also lighten up here. Now this is player O's turn. Um, let's say the player O will give his input to top left corner. Here we can see the O symbol is lighten up on our LED display here, and also here we can see that O is shown in our LCD display too. Let's play for a win for in any player. Let's say the inputs will be like this, and then player O will give input to top right, and then he can give in middle row. look at the LCD, it now shows that player X won, and below we can see there is press any key. If I press any button, then the game will restart. Here we can see the player X has won. This is shown on our LCD display, as well as whenever we look at the LED, we can see the they completed a row. The X player has completed a row. So now if we press any button, the game will restart. So if we press any button, the game will restart, and now we can see there is a fresh LCD display, and also the LED is also cleaned. Now let's play for a draw condition. Suppose player suppose player X will give input to top left corner, and gradually the let's say player 0 will give input to middle, then player X can give it to here, the bottom right corner. Player 0 can give it on the middle row, bottom middle row. Then player X can give it to here, player 0 can give it here. We can see whenever we are giving input, as well as the LED, the LCD is showing wherever we are giving input, I mean wherever the player is giving input. Oh, there is a mismatch, and here player 0 has won. We just simulated another condition whenever player 0 has won. uh, let's say let's simulate for a draw condition. Let's say let's keep some random. Let's say this is the condition where neither player X or nor player 0 can win this game. If we input here, let's look at the display. It's a draw. And in the LED display, we can visualize the game that this is a clear draw. Neither player X nor player 0 has won the game. Now we can switch to player versus AI mode, and then we clear it up. Now we can and on the LCD display we see PAI. This means player versus AI mode. The human plays X and the AI plays as 0. Let's say I'm playing as player X, and the AI will play as player 0. Let's say I play center. The AI responds instantly without any button press. See this, the AI has inputted his move on the top left corner here. Let's say I will then again play my move on top right corner. Mm, then AI gave it to, we can see the LED, the AI gave it to the bottom left corner, and gradually let's play the game with AI. Mm, so I and the AI have completed our moves, and we can look at the LCD display that it's a draw. So here is the full walkthrough of this tic-tac-toe game and how it is played. Thank you.